Hey guys, it's Ben here with Minutes Till Minutemen, here to talk to you about Meshtastic. If you haven't seen my previous videos, I go over a build, a pocket size mobile build that has a GPS and barometric sensor, so go check that video out. This video is going to be more about software and programming and things that I learned on the way that other people did not show or really give light to the fact that these things need to be programmed properly in these certain areas of the settings. So that's what this video is going to go over. And I also made a previous video about what Meshtastic is and a basic overview of how you can use it for off-grid communication and different ways that you can tailor it to your specific needs. So go ahead and check those videos out. All right, and we're going to start to get into this video now. This is the homepage of meshtastic.org. You have pretty much everything here, all the forums you can get through here, the GitHub pages, and you can get the documentation and download that from this page. You can also download things from this page. It'll be stuff for mobile, so Android and iPhone. You can go to this page or go to your Apple or Google Play Store. It also has Python command line interface download for you to be able to go through the terminal if you're into that and you're trying to do a little bit more. That is for more advanced users, and I think that most of us will be fine just doing it through the way that I'm going to show you right now. This is the homepage. Has some basic steps of getting started here, and iOS app, Android app, web client, Python app, command line interface. So we will mostly be using iOS and the web client. This video is going to be pretty much all on the web client, and that's where you're going to be able to program the majority of your settings. At least for me, I know that iOS and web client, they have a lot of the same material, but some of the stuff it's better on the iOS side, and for some of the settings it is better on the web client. So you're going to want to learn how to use both and how to program things with both. Alright, if we go back up to the top here, we can see this downloads button. We can go to that real quick. So there is a web flasher. You're going to want this most definitely for flashing to your nodes to have the most up-to-date firmware for it. Now, for a note, the Heltec, you can plug it directly in and it will flash it from your browser. But with the Rack WizBlock, you have to download a zip file and basically just drag and drop it to your node when you have it plugged into your computer. It will notice and recognize it in the file system, and that's all you have to do. It will boot itself up automatically. Then you have the Apple app, Android, and then the web store. And then it also has the firmware. So basically what the firmware is, there's stable, which is, it's exactly what it sounds like. It's stable. Alpha is for more people who are willing to take risks to try out newer features, and bleeding is kind of like do your own thing, break it, and rebuild it. So we're not going to touch probably just alpha and bleeding. We're probably just going to stick with stable, because that's going to be more tailored to being consistent and being able to not have any malfunctions while we're trying to do operations. Alright, if we go up to the docs page, it'll give us their whole tree of different things about introduction, getting started, configuration, hardware, everything that you need here. This is downloadable. I forget exactly how to download it. I think it's through GitHub, possibly in that top right corner, but this, I know I have it on my phone, and I also have it downloaded onto my local laptop here. This is a great resource. I'm not going to go over it a whole lot, if at all. I might come back here to reference some stuff, but as for now, this is pretty easy to understand. It goes through stuff. It just leaves some things out, and that's what I want to have this video help you on, because I was able to read through all this documentation here, and some stuff it did not really go over or say. So we're going to try to help you do that here. All right, we're going to go on to the next tab, which is the Web Flasher. You're going to select your device, and they've updated this so it has pictures and it actually looks really cool. We're going to select the Rack WizBlock 4631, which is our core. Does not matter what your base board is, base module. It's just whatever core is on the board. And there you see some other popular things like the Heltec V3 down here, and the brand new Heltec right here, the Stick Light. So Heltec is definitely trying to make newer nodes. Then you have the T-Beam, and then right here you have the Rack WizBlock. We can actually press the 4631. Now it's going to ask you for your firmware, and you're going to select what firmware you want. You're going to want the stable version, the latest stable version, which is at the top. So that's 2.5.20, and that is the best one as of yet. We are making this March 1st, 2025, so things will definitely change, but these are the unstable versions, and we just, again, don't want that because it could leave a lot to be desired and really is unstable and could potentially lead to issues when you need the least amount of issues. So if you're trying to just test these things and have it more of a hobby, go ahead, do the unstable. But if you're trying to just be able to have secure communications that are reliable for a good price, then I would stick with the stable. And then you have the flash button. It's going to ask you a bunch of things, let you know about a couple things, and then you're going to press continue down here. And then it's just wanting you to enter the DFU mode, which is basically just its boot process. And then you'll click this download UF2. Like I said, it's just going to download that zip file to your file system in your downloads. Then you're just going to drag and drop it into, it's going to come up like it's a USB device. It's going to come up as its own separate, the rack module. And you're just going to drag the unzipped file into the 4631 that pops up, and it's going to boot itself. So that's different from the Heltec, because the Heltec will actually just give you a little terminal window. It won't say download UF2 here. It'll say start or something to that effect, and it will update the firmware on the node with the Heltec. I have not had a T-Beam, so I don't know how those work or anything else. The only things that I've had are the Heltec V3 and the Rack 4631. All right, we can move on to the next thing. This is a pretty new development. It is by Rack, and it is a virtual little representation of your node, so it's going to help you with compatibility issues and preventing those, and help you understand which modules can go where and what module you need. For instance, the core, if you are in North America, it needs to be 915 megahertz. They don't want you to buy a 800 something megahertz when you're in America, because that would not be allowed. This is my setup that I have right now. It is a, let's see here, go back to the base module. It's mini baseboard. It's the Rack 19003 with the Rack 4631 core. And for the sensors, there's only two slots. There's only a C and a B slot. C and D slot. So one of them we have is the GPS sensor, and then the barometric pressure sensor. So pretty cool little web design here. It's really cool what they're able to do, and to really, this is kind of cool for being such a new thing. Meshtastic, granted, it's been out for a year or two or a couple years, but this is cool that it's been really quick to develop these things to help users. So that's what I've got. Here's some tools. This is a radio frequency RF line of sight tool. See what radio frequencies can be seen, or where you can transmit and it will be picked up. So say you're transmitting where this little crosshair is, and it's showing you where that radio will be able to be touched, and you can set the height of that node with this, and you just are able to click and it'll show you how far away it is. It'll give you these two things up here. It'll give you the vertical scale here, see what other mountains are around and what interference you have, so you can base it off of that, and then it gives you this graph representation of the different areas on the way. And say you want to select that area on the graph there, it'll actually show you where that is with a green crosshair down here. So that's pretty cool. Again, this is just one tool that you can use to help set up nodes and their locations. And then here is another tool, more basic, but basically you have these two pin drops, and you put one in one place, one in the other, and then it has this graph over here. And if the line between the 2 points is green, that means that they're able to communicate with each other because it has line of sight. But if it's red, I'll just drop the height here. I'm able to move it here, and the line becomes red there. So that just means that it doesn't have line of sight. All right. So those were just some tools that are able to help you. Now we're going to get into the actual development side of the radio. So this is I'm running the 4631 from Rack Wireless, WizBlock, but this is completely factory software. So I checked, it has updated software, the up-to-date one, but everything else is bare on this device. So we're going to plug it in and connect to it. All right, so we've connected our device, and we're going to go over here to the new connection button, and we're going to hit either Bluetooth if you're using Bluetooth, or serial. I'm using serial because I'm using the cable provided in the packaging with the WizBlock and the core. And here is my device right here that came up because I already had it connected. But if yours does not pop up like this, you're going to hit new device, and it should have it here in this window. If it does not have it in the window, then you need to check and make sure that everything's plugged in, your node is turned on, and that Chrome is not hindering the connection, that it is allowing it. I'm just going to hit this right here, this guy, and here it is. Here's a node. So it gives you some stats up in the top left corner here. The name of it, the short name first. It gives you this backup reminder in the bottom right. Okay, it's going to give you the short name, and then it's going to give you the long name. So the short name is E5F2, and the long name is Meshtastic E5F2. So a lot of people will leave these. I've seen just the default. I like to change these so it helps you to remember who you are, those who communicate with you. But anyways, what we're going to do is talk a little bit about what it is at right now. What is the capacity of this node? It is able to not communicate yet because you need to set the LoRa region, which is going to be US 915 for America, and based on where you're at, we're going to address that in a second. But right now the node has one channel. It is the default channel of it literally says channel 0 or default or primary channel. Yep, messages, you can see it right there, messages primary. So that's default. There is another name that will work with this. It's long fast, which is also technically the default name. And this is where the default encryption key is AQ ==, and everyone that is able to receive your transmissions will be able to see those messages. This is also the primary channel, which means that all your information is being transmitted over this line, which is not good for being secure. It is fine if you are doing this for hobby. Even then, I'm a little bit wary of it because then people can track your location when you're not meaning for them to. So first we're going to go to the Configure tab, and then we're going to go to LoRa. Now this first one is region, and it is unset. So we're going to click it. We're going to press US. Now the hop limit is the amount of hops that can go through other nodes. So right now, if I transmit it, it'll go through, let's just say node number 1. Sorry, it'll actually be technically node 0 because of the way that the computer counts. Weird, but that's how it is. So node 0, which is technically node 1, but we're just going to keep it like the computer sees it. Then it's going to be node 1 and passing it on to the last one, which is node 2. And it will not transmit after that node. Even if it hasn't reached the destination that you want, it's too bad. It has reached the third and final node. So that's where this hop limit can come into play, but this also creates network traffic. If you have a lot of nodes in one place, you do not want to set this high because they will all be broadcasting and you will not be able to get messages through. Frequency slot, we will go over this later once we change our primary channel, so we'll leave that there for now. Ignore MQTT, that's just if there are any messages coming from the internet over a node, that it will ignore those. So you can click that on or off. OK to MQTT. When set to true, this configuration indicates that the user approves the packets to be uploaded to MQTT. If set to false, remote nodes are requested not to forward packets to MQTT. So what this is for those nodes that are connected to the internet, this will just tell those nodes that your transmissions are to not be uploaded to the internet. So the first one is for you to be able to receive those messages from the internet. The second one is so that you can either allow and deny your messages to be uploaded to the internet. These are the different base settings. We're going to use long fast here, but you can change this if you would like, but you will not be able to communicate with other nodes, the majority of nodes in your area. This changes the frequency and the waveform of the LoRa signals, which means that nodes on other presets will not be able to receive that message. So we're going to leave this long fast. This is to change these settings would be to make it so that either if you are trying to transmit a short distance, that it transmits quicker, or you could make it so that if you're transmitting long distances, that it takes longer to transmit, but it will be able to more reliably receive long distance and transmit long distance information. The bandwidth, the spread factor, the code rate, that is all done by the long fast, or you could make a custom one, which is if you click this little switch here, it'll allow you to set your own megahertz bandwidth, that kind of stuff. We're going to use just this preset because that works perfectly fine. Long fast is the middle ground of speed but reliable transmission. With each end of the spectrum, you have shortcomings. There are trade-offs for everything. So like I said, you can either transmit really quickly, but if it's a medium to long range distance, it will most likely not be able to reliably transmit and receive. Or you could do it very slowly with the transmission, but it would be more reliable, but it would take way longer, and sometimes that's also not good. So we're going to just leave it as long fast. Radio settings, if you're not ready to transmit, you can click this off. We're going to leave it on just because if you're working with this inside, it will be fine. It won't be able to really go through any walls. The transmit power, that is pretty much hard set unless you have special licensing from the FCC. If you are licensed as a amateur ham radio operator, then you can up the power with this, but then it will deactivate the encryption. So we're not going to do that, obviously, because we want the encryption. That's what this override duty cycle is, I believe. I actually don't know. I'm going to have to read up on that. Frequency offset. This is more advanced, but if you're not receiving properly or you're trying to fine-tune the frequency that you're working with, you can offset this the frequency. That's more of an advanced option. We're not going to do that right now. Then boost RX gain, we're going to want that, and then the override frequency, just going to leave that 0. All right, we're going to scroll back up to the top here, and we're going to press this save icon on the top right. So it's going to save the node. Okay, now we are, another backup reminder. So I do have to say that for some reason with my laptop, it does not like to reconnect to the node. So when you save these settings to the node reboots, and for some reason it like crashes or freezes the Meshtastic Web interface. So I have to reopen it and reconnect via serial. I don't know if that's just me or if that's a common occurrence, but I just found to work around it. It doesn't affect the node itself, but it is just kind of annoying. We're going to go over to device now, and we're going to just look at some of the things here. The role, we have client right now. In the documentation, it goes over all of these different things. Some things to note is the TAC, that is to use with ATAC, and TAC tracker and things like that, and router repeater, client mute, but we're just going to use client for now. There is the client hidden and client mute. Just be aware of what all those things and choose what's best for your application. Now I have different button pin, and this is meant for multiple different modules. So since this node has a lot of stuff already built in, like the sensors that you just plug and play, a lot of this stuff is not soldered in that you have to do yourself. So a lot of these things don't apply to this node, which is great because you have to do less with setting them up. Then we have rebroadcast mode here. It's just saying, do you want to broadcast all the traffic that comes to you? Do you want to just transmit local traffic? Would you like to only transmit known nodes and things like that? We're going to leave it to just the all for now. The broadcast node info is just how many seconds until the next time it sends out data, like its battery percentage, what node it is, GPS location over the primary channel, and sensor information. Then we have just things. These are more for, the bottom one is for ours, but the disable triple click is not for us, and the treat double tap as button press is not for us either. These would be for different uses with different nodes, but we're going to just leave those like it is. Then position, we have it enabled. I think it does already come enabled. We leave smart position on just because it'll use less power, because it will see that we're in the same general location, and it will not transmit that over the mesh. Now here are, like I was talking about, if you solder in your own GPS, which you have to do with the Heltec V3, you have a receiver pin, which is what the GPS is actually transmitting on. The receiver pin is what the node is receiving on. That's something that can get you caught up. Ask me how I know. Then you have transmit pin. That is the receiving pin of the GPS that you soldered in. And then we have enable pin. That is the pin that turns the GPS on and off if you choose to include that in it. For the Heltec V3 that I built, I only have the receive pin and the transmit pin, but the enable pin I don't have. Something to note with this is that with this 4631, it already has this stuff built into the firmware, so we do not need to enter these pins, which is nice. Has just the different broadcast intervals and the distance that it needs to travel for the node to consider it a distance enough to send a update over the mesh. All right, that's just some of the basic stuff. We have like power, things like that. Display, we don't have a display on the 4631. You can put one on if you wish, but we don't have it. Then we have LoRa, which we just went over, Bluetooth. So you can either have Bluetooth enabled or disabled. And we have a fixed pin, because if we had a random pin, we would not be able to know it because we don't have a screen on this. So we're just going to do a fixed pin. Default is 1, 2, 3, 4, 5, 6. You can set it to whatever you want here. Security, we're not going to go too much over this right now. This would be if you were to use that Python CLI command line interface. That's a little bit more advanced, so we're not going to go over that right now. We're going to go down to channels, and this is where the fun happens. So this is the programming for the channels. So as you can see, there's only one channel. It's the primary channel, and there is other channels here, but they're all disabled because they're not theoretically there. So that is that. So what we're going to do here, this video is more about if you're building it from scratch, but there are ways to, if you have channels already, that you can you don't have to delete all the channels to change this primary one, because you can't just go into channel number 1, channel number 2, and select primary or secondary. That's not how that works. We are going to change this so it's 8-bit encrypted. There it is, the AQ equals. That is the default pre-shared pin, and since it's the primary channel, this is what the information of the node transmits over. So this is not good because it's letting everyone that has access to this channel, which is everyone that has Meshtastic, that's able to receive your transmissions, can intercept this. That's on the right frequency, but pretty much all of them have the same frequency of 915 with this primary channel. We are going to change this to 256-bit, and we're going to hit generate. And we're going to hit regenerate, and there is the key right there. So we're just going to leave that as is. So there is this name column here for you to enter your own name for the channel. So we'll just do this MTM for minutes till Minutemen. And something to note with this is now that we have changed the pre-shared key, which is the encryption, and now that we have changed the primary channel name, the frequency is actually going to be a little bit different. So right now, if we just leave it as is, like it is right now, if we try to transmit over the mesh, it will not be picked up by other nodes because it isn't off of the same frequency that those nodes are running on. So what we're trying to do here is to create a private, basically, primary channel so that we can send information over that primary channel that's private. But we're going to want to go back after this and input a frequency setting that makes it so that we go back onto the mesh network of those nodes around us that have long fast as the primary channel still. So I'll show you how to do that, but right now we'll keep going with this. Uplink enables, that's letting this channel get uploaded to the mesh, the MQTT, so the internet, so the Meshtastic servers, or creating your own server. Downlink enables, This is sending a message from MQTT to the local mesh, so that's for you to connect to the internet. And if you would like to take the stuff from the internet and then transmit it over LoRa, that you can switch that on or off. Allow position requests. So this one, it has to be, it will not allow me to do the switch off for send position requests because this is the primary channel. There's two settings here for position. There's one of send position to channel and one of send precise location to channel. So you will always have to send location, send position to channel. It'll give you a rough estimate of where you are, so it's not completely not safe, but still we want to try to make this as a hardened object for people to find where you are. So we'll actually set these both to precise locations, so people on your encrypted channel that only you guys know about, only those people will be able to see your location, and they'll be able to see your precise location, so that's good. And then here's the approximate location. That's just if you did not select this precise location switch. All right, so we're going to just look over everything, make sure it is what we want it to be, and then we're going to hit submit down here at the bottom. Now, that submit will not reboot the node. It will just kind of save it to the channels. All right, now we can go up to channel 1. And if you wish to add more channels, you can add as many as you like. You can, so this one has to be secondary. You can select 8-bit, and then you can put in the default AQ equals, and there we go. So that's the default encryption for the long fast channel. The name, a unique name for channel, we can either leave this blank. I want to change it to long fast, so that's what we're going to do. So right here, this is the name for the default channel that we had before, but now we can still communicate with anybody that's around us that's not a part of our group, that doesn't have our encryption, but we still want to talk to those other people that like Meshtastic or that are using it. So that's still a good thing. And then you can set positions if you would like, but we're just going to leave these blank, obviously, because the reason we changed the primary channel was so that we don't send position over that. So now this channel we can communicate with, but they will not receive information, and they will also not be able to find out things from you more easily because it's not defaulting to send that information and data over that channel. Yeah, I hope that makes sense. I've been just trying to make it more understandable. So we're going to hit submit again for this channel. Okay, so now that we've done that, we're going to set that frequency slot. So we're going to go back over to the configure, and we are going to go to LoRa. Now that we see the LoRa frequency slot is 0, this is just default because when you change the primary channel name of the node, it will change the frequency slot. So that just means that it'll shift the frequency that it transmits over, and other devices and your device will not be able to communicate with each other. So we're going to go back to the documentation of this Meshtastic page. There is a frequency slot calculator for you to know, okay, frequency slot 1 for long fast US region transmits over what? And right here it shows it transmits over 902.25. If we go down to North America frequency bands, we can see that there are 104 frequency slots with the preset long fast, and the factory reset, the radio will be to frequency slot 20. So we're going to want frequency slot 20 so that we can still transmit over 915 using the mesh network around us. So we're going to go back to our node here, and we're just going to type in 20. And now that we've done that, we're going to go up to the top here and press save. Alright, so after we set up the frequency slot there, now we have that set up so now that we can transmit over the mesh network around us using other people's nodes, but our primary channel, which transmits telemetry data, is not transmitting over the default channel. So this is what we want, and now really all we have to do is change the name. I do have to note with this process, a lot of this stuff is easier on the mobile app version. So you can pretty much do all of this except for really the node flash of the firmware. The firmware flash, you can sometimes do it. Actually, some modules allow you to do it over the app, but it's really just way more simpler to just plug it into your computer and have the web flasher do it from there, and it's really easy that way. But this web interface to program the node and to change channels and stuff like that, I feel like it's a little lacking. The mobile version is actually a lot more intuitive and a lot more just easy to use and has less hiccups. So we're going to hit this little checkbox up in the corner, and it'll give me the long name and short name. So we'll just do long name is minutes till minute. It might not allow me to have everything include the whole name in here, but we'll see. We'll just do 25, or so, yeah, 25. And the short name we'll do MTM 25, 5. Boom. And we'll do save. And now it should reboot the node. Alright, and now we have the node back, and we can see that the name has changed, and both the long name and the short name. So that's awesome. This is exactly what we want. And we can go into configuration and change even more settings. These are the radio settings, and then the module settings are your telemetry and sensor data. So just a lot of cool stuff that we're able to do with this. And there's a map here. We can, if we put this outside or close to the window, it will transmit our location. But it is a really cool thing that you can do this with, but the app is honestly a lot more enjoyable to use. So that's it for this video. I hope you enjoyed. We will hopefully do a range test. I would like to correct quickly some things I said in my last video that are not correct. For one, the battery life of this new node is definitely more. It's about 2 days more, but it's still not a full week. This one node stayed on for about 4 days with one 18650 battery, which is pretty good with the GPS constantly on, but still not up to a week, which I was hoping. But it's definitely 2 days longer than the Haltech V3, and honestly a lot more portable, and I'm able to hang it from like a hook in my car and just drive around to work and back from work with this device. And I was able to pick up about 63 nodes within 3 or 4 days that it was running constantly. So that was pretty nice. Sorry about that one. But also about the module, the sensors that you can put on this specific module. You can actually put many that will, it looks like the pins will overlap. I got wrong information from Rack Wireless. Even though they make the module to work with Meshtastic, they don't know all the ins and outs of Meshtastic and how it works. Meshtastic is able to pull all the data all at once. I just had a setting wrong with my node with the GPS. It was giving me this big wide circle, like it wasn't properly pulling the information, but it actually was. I'll go and show that to you real quick. What you're going to do is you're going to go to the channels down here. You're going to go to your primary channel, and you're going to scroll down to set precise location to channel. Actually, I think you can do that in the app. I'm not sure, but I definitely know that this is how I was able to do it, and how the guys at Rockland were able to help me out through this. And I thought the GPS was bad, was I had to send it back, but actually it was just me not understanding how to use it properly. So there's that. And yeah, so this is the module. Hopefully gonna do some more videos in the future about range tests and how far these things can communicate, and possibly putting a node up on a mountain top nearby where I live, and just seeing how that goes, who I'm able to pick up, and if I'm able to use my handheld device and communicate with the one that I put up on that mountaintop. So stay tuned. Please subscribe and like, add comments, what I can do better, what you liked, what you disliked, and any questions you had. Really want to try to help as many of you as I can, and help you through this process of really building these out to be specific and purpose-driven, so that you can use these as your off-grid communications that are very reliable, and hopefully one day you won't ever have to use it, but that will be able to help you save lives and potentially your own life and your families. So thank you for watching, and we'll see you in the next video.